power company's proposal of using a secondary service, stepping up to primary voltage, and then stepping back down involves efficiency losses, additional equipment, maintenance, and safety concerns. Voltage transformations inherently involve energy dissipation, which reduces the overall efficiency of the power system. Transformers and associated infrastructure require increased installation and ongoing maintenance costs. Handling high-voltage primary power demands specialized expertise and rigorous safety precautions. Installing a customer-owned and maintained primary line from the power pole to a transformer pad near the house is generally more feasible. Primary power distribution offers greater efficiency than relying on secondary service, leading to reduced energy expenses. The customer assumes responsibility for maintaining only the segment of the primary line, which lowers overall maintenance costs. Primary power lines are often more reliable than secondary lines, thus lowering the probability of power outages. The refusal to sell primary power to residential customers might be considered unusual. Typically, utilities are required to extend primary service to customers when they meet established criteria, which may include distance from a distribution substation and specified load requirements. If the power company remains unwilling to provide primary service, several alternatives should be considered. Firstly, try to negotiate a customized agreement with the utility company that would permit the installation of a customer-owned primary line. Secondly, explore alternative power sources to supplement or replace grid power, such as solar or wind power systems. A consultation with a local electrical contractor can provide expert advice and can help in finding alternative solutions that meet requirements and adhere to regulations. Electrical contractors can assist with evaluating the feasibility of the power company's proposal, assessing the costs and benefits of customer-owned primary lines, and exploring alternative power solutions. They can also ensure that the chosen solution complies with all applicable electrical codes and regulations. Some more details to consider regarding the initial proposal. Firstly, the power company proposes providing a secondary 240/120 volt service with a customer responsible for stepping up the voltage to primary levels. This requires a step-up transformer at the road. Secondly, the customer would then bury a coaxial primary cable under the driveway, leading to another transformer near the house. Thirdly, the second transformer steps the voltage back down to 240/120 volts to feed the house. The issues with this proposal firstly includes efficiency losses due to the double transformation. Secondly, there are increased equipment costs for two transformers and the primary cable. Thirdly, the maintenance cost associated with two transformers increases. Fourthly, the complexity of the system increases the risk of failure. Fifthly, this setup may not meet electrical code requirements for residential services. Turning now to the alternative of a customer-owned primary line, firstly, this eliminates the double transformation, improving efficiency. Secondly, it reduces the equipment cost to one transformer. Thirdly, the maintenance is simplified with only one transformer. Fourthly, it simplifies the system, reducing the risk of failure. Fifthly, the setup is more likely to meet electrical code requirements. When considering the alternative power sources, remember, firstly, solar power offers a renewable energy source, reducing reliance on the grid. Secondly, wind power is another renewable energy source, particularly effective in windy areas. Thirdly, batteries can store energy from solar or wind, providing backup power. Fourthly, generators can provide backup power during outages. Fifthly, a combination of these alternative sources can create a more resilient power system. When discussing negotiation with the power company, consider that firstly, you can propose a cost-sharing arrangement for extending the primary line. Secondly, offer to handle the maintenance of the primary line. Thirdly, provide data on your energy needs to justify the primary service. Fourthly, highlight the environmental benefits of a more efficient power system. Fifthly, emphasize the potential for future growth and increased energy demand. When working with a local electrical contractor, firstly, ensure they are licensed and insured. Secondly, check their experience with similar projects. Thirdly, obtain multiple quotes for comparison. Fourthly, verify their knowledge of local electrical codes. Fifthly, confirm their ability to obtain necessary permits. Additional points concerning the Niagara Mohawk's practices. Firstly, inquire about the specific reasons for denying primary service. Secondly, request a written explanation of their policies. Thirdly, investigate whether other customers in the area have received primary service. Fourthly, consult with an attorney specializing in utility regulations. Fifthly, file a complaint with the New York Public Service Commission if necessary. Additional safety considerations for high-voltage systems. Firstly, ensure all work is performed by qualified professionals. Secondly, use appropriate personal protective equipment. Thirdly, follow strict lockout/tagout procedures during maintenance. Fourthly, install proper grounding and bonding systems. Fifthly, conduct regular inspections and testing of equipment. For the customer installed primary power lines, firstly, the customer needs to adhere to all applicable electrical codes and regulations. Secondly, the customer is responsible for the design, installation, and maintenance of the primary line. Thirdly, the customer must obtain all necessary permits and approvals. Fourthly, the customer should consult with a qualified electrical engineer to ensure proper design and safety. Fifthly, the customer should implement a regular maintenance schedule to prevent failures. For step-up and step-down transformers, firstly, the transformers must be properly sized to handle the load. Secondly, the transformers must be installed in a safe and accessible location. Thirdly, the transformers must be protected from the elements. Fourthly, the transformers must be regularly inspected and maintained. Fifthly, the transformer should be equipped with appropriate safety devices, such as fuses and circuit breakers. Some additional points about the efficiency losses of secondary service. Firstly, secondary service has a high voltage drop over long distances. Secondly, secondary service requires larger conductors to carry the same amount of power. Thirdly, secondary service results in increased energy waste. Fourthly, secondary service can cause voltage fluctuations, affecting the performance of sensitive equipment. Fifthly, secondary service is less reliable than primary service, with a higher risk of outages. Some additional information about the cost of customer-owned primary lines. Firstly, the initial cost of installing a primary line can be significant. Secondly, the ongoing maintenance costs can be substantial. Thirdly, the cost of permits and approvals can add to the overall expense. Fourthly, the cost of insurance and liability coverage must be considered. Fifthly, the long-term savings in energy costs can offset the initial investment. Some additional information regarding negotiating with Niagara Mohawk. Firstly, be prepared to present a strong case for primary service. Secondly, be persistent in your negotiations. Thirdly, be willing to compromise and find a mutually agreeable solution. Fourthly, seek support from local government officials. Fifthly, be prepared to escalate the issue to higher levels within the company. If considering alternative power sources, be sure to research and consider firstly the availability of sunlight or wind in your area. Secondly, the cost of installing and maintaining the alternative system. Thirdly, the environmental impact of the alternative system. Fourthly, the reliability of the alternative system. Fifthly, the potential for energy independence. If consulting with a local electrical contractor, make sure firstly to check their references and reviews. Secondly, ask for a detailed breakdown of costs. Thirdly, ensure they are familiar with local codes and regulations. Fourthly, obtain a written contract outlining the scope of work and payment terms. Fifthly, verify they have the necessary insurance and licenses. In considering voltage drop over a long distance, you should know that firstly, the longer the distance, the greater the voltage drop. Secondly, the smaller the conductor size, the greater the voltage drop. Thirdly, the higher the current, the greater the voltage drop. Fourthly, the voltage drop can affect the performance of electrical equipment. Fifthly, it is important to calculate and compensate for voltage drop in long circuits. Also consider conductor sizing. Firstly, the conductor size must be adequate to carry the load. Secondly, the conductor size must be selected based on ampacity and voltage drop requirements. Thirdly, the conductor size must be appropriate for the installation environment. Fourthly, the conductor size must comply with electrical codes and regulations. Fifthly, the conductor size should be chosen to minimize energy waste. On the topic of energy waste, firstly, inefficient appliances and equipment contribute to energy waste. Secondly, poor insulation leads to energy waste. Thirdly, standby power consumption wastes energy. Fourthly, improper lighting wastes energy. Fifthly, energy waste increases utility bills and environmental impact. Voltage fluctuations. Firstly, voltage fluctuations can damage sensitive electronic equipment. Secondly, voltage fluctuations can cause lights to flicker. Thirdly, voltage fluctuations can affect the performance of motors. Fourthly, voltage fluctuations can be caused by grid instability or equipment malfunction. Fifthly, it is important to identify and address the causes of voltage fluctuations. When considering reliability, firstly, primary service is generally more reliable than secondary service. Secondly, underground lines are more reliable than overhead lines. Thirdly, regular maintenance improves reliability. Fourthly, backup power systems enhance reliability. Fifthly, a well-designed and installed electrical system is more reliable. The initial cost of installing primary lines is significant. So, firstly, consider the cost of materials such as conductors, transformers, and switchgear. Secondly, consider the cost of labor, including trenching, installation, and connection. Thirdly, consider the cost of permits and approvals, which can vary depending on the location. Fourthly, consider the cost of engineering and design, which may require specialized expertise. Fifthly, consider the cost of insurance and bonding, which is necessary to protect against liability. Ongoing maintenance costs can be substantial, so firstly, consider the cost of regular inspections and testing. Secondly, consider the cost of repairs and replacement. Thirdly, consider the cost of vegetation management, such as tree trimming. Fourthly, consider the cost of emergency repairs and outages. Fifthly, consider the cost of insurance and liability coverage. The cost of permits and approvals can be a factor to consider. So firstly, research the permit requirements in your local jurisdiction. Secondly, obtain all necessary permits before starting any work. Thirdly, comply with all applicable codes and regulations. Fourthly, be prepared to pay permit fees, which can vary depending on the scope of the project. Fifthly, work with a qualified contractor who is familiar with the permitting process. The cost of insurance and liability coverage must be considered. So firstly, obtain adequate insurance coverage to protect against property damage, personal injury, and liability claims. Secondly, work with a reputable insurance provider who specializes in electrical systems. Thirdly, review your insurance policy carefully to ensure it provides sufficient coverage. Fourthly, update your insurance policy as needed to reflect any changes in your electrical system. Fifthly, implement safety measures to reduce the risk of accidents and injuries. Long-term savings and energy costs can offset the initial investment, so firstly, calculate the potential savings in energy costs over the lifetime of the system. Secondly, consider the impact of energy efficiency measures, such as LED lighting and energy-efficient appliances. Thirdly, take advantage of any available incentives or rebates for energy efficiency upgrades. Fourthly, monitor your energy consumption regularly to track your savings. Fifthly, invest in energy-efficient technologies to reduce your carbon footprint. Presenting a strong case for primary service to Niagara Mohawk. So firstly, gather data on your energy consumption and load requirements. Secondly, demonstrate the economic benefits of primary service, such as reduced energy costs and improved reliability. Thirdly, highlight the environmental benefits of a more efficient power system. Fourthly, emphasize the potential for future growth and increased energy demand. Fifthly, be prepared to address any concerns or objections raised by Niagara Mohawk. It will be important to be persistent in your negotiations with Niagara Mohawk, so firstly, schedule regular meetings with Niagara Mohawk representatives. Secondly, follow up on all communication promptly. Thirdly, document all discussions and agreements in writing. Fourthly, be patient and persistent in your efforts. Fifthly, don't give up easily.